Böyle yapsak.
Good morning, dear participants. My name is Tanyeli Sabuncu. I'm leading the Climate and Energy Program at WWF-Türkiye. Welcome to our webinar on natural building materials and methods. So I would like to remind you that this webinar is being recorded so that we could share with the rest of our network and the rest of the OPCC participants. For those of you who have difficulties in English, you may use the interpreter section. This webinar is being interpreted to Turkish. So today, this webinar, we are conducting this webinar as a part of the strategic program of One Planet City Challenge, WWF's global initiative to inspire and support cities around the world for bolder climate action. Today, we are here to talk about natural building materials and methods and how they could make cities climate resilient and lower emissions. When we cooperate with nature to build our living spaces, we can not only avoid extractive and massively energy-intensive processes, we therefore embedded emissions, but also make our homes warmer in winter and cooler in summer and more resistant to floods, fires, and earthquakes. In 2023, following the massive earthquake, which impacted 11 cities at southeast of Turkey, WWF-Türkiye collaborated with Natural Building Materials and Methods Association to conduct a study on natural building materials and techniques in the country and how they could make our cities resilient to disasters. Following an extensive research on the ground, we published a report last year. Today, our experts will be sharing the findings of this report with you. Not only that, we will also be sharing examples from Rosny-sous-Bois, a city of France. So we have 4 distinguished experts today who will be sharing their information with us. Merve Titiz, co-founder and vice president of Natural Building Materials and Methods Association, also co-director of the Institute of Building Biology and Ecology in Turkey. She will be sharing insights on building awareness and community for healthy and natural buildings. And Ant Akban, co-founder and vice president of Natural Building Materials and Methods Association, also co-director of the Institute of Building Biology and Ecology. He'll be sharing insights on the diversity of natural building materials and their holistic performance and assessment. We also have Professor Matteo Pedergnana. I hope I mentioned your name correctly, Matteo. And he's the board member of the Natural Building and Materials Association, also architect and a faculty member at Yaşam University in Izmir, Turkey. And we also have Charlotte Picard, who's the deputy director of Research and Innovation Unit at the city of Rosny-sous-Bois in France. So without further ado, I would like to give the word to our speakers. Let's start with dear Merve Titiz as the before giving the word, I also would like to remind that dear participants, you can share your questions with us through the questions and answers section. We will be answering them once at the end of the presentations. So sorry for interrupting you. Merve Hanım, the floor is yours.
Thank you very much, Daniel Savuncu. First, I would like to start with our holistic approach to buildings. In the next slides, you can see if we can go to the. Can I go to the next slides myself? No.
Yeah.
Okay. So, in general, I would like to speak about our Building Biology and Ecology Institute's approach, which is a very holistic approach with 25 different principles covering 12 different areas. Some are related to natural building materials, insulation, indoor climate, geological suitability of the building, to environmental energy and water cycles. So since it's very holistic, it's also an interdisciplinary working field. So we also are feeding ourselves from sociology, biology, chemistry, from different disciplines. At the same time, it's in the intersection of health, architecture, building technologies, and building economy. So we need to work with people together, with experts together always. And next slides, when we founded 10 years ago, the Building Biology Institute in Turkey, we started a wide awareness raising work. At the same time, anyways, we understand that without natural building materials, we cannot really construct natural and healthy buildings. In the next slides, okay. Can we go to the next slides? I think we skipped some slides.
Just a second, I need to reshare my screen due to a technical problem. So sorry about that. I need to try another plan.
No problem. I'm a bit stressful because of the time. That's
For some reason, the Teams. Now it's full screen. Perfect.
Okay,
nice.
nice.
Thank you very much. Can we go to 2 slides or one more? One more. I think 2 more. I think slides earlier. No. We are going. We should go backwards.
Okay.
To the beginning.
To the beginning. Okay. Here is okay. So 10 years ago, we founded the institute, but as I said, while our awareness raising campaigns, we also understood that without natural building materials, we cannot do too much. So we need some kind of a working group. We started in 2018, and we started to meet every month with 3.5 years. With different people interested, having experience in natural buildings, and this created a real community, building community, which evolved to Natural Building Materials and Methods Association in 2021. We founded the association with 15 members of the group. Okay, so here you can see some pictures from the meetings, from the technical speech. So yeah, the next slides. So the main aim of the association was to promote sustainable solutions for built environments that are in harmony with the natural ecosystem. We can go further. Next slide. Yeah, we have a framework. Surely, when we say natural, it doesn't happen to be natural. We have 6 different criterias. One, we start with if it will be a mineral, raw material, we shouldn't have systemic influence on the earth, ground. When in the construction phase, we should really choose the most lowest carbon emission solutions. While the materials has to be natural, but it has to also support human health in the indoor environment. And plus, try to support the energy efficiency and the health of the building. At the same time, embedded energy is very, very important for us. This means that in the production phase, we also need low-tech, low-carbon emissions. While in the process of buildings, these materials has to have similar performance as conventional materials. Like if it's an insulation material, it has to have a high insulation rate, for example. And very important also that first, as much as possible, they shouldn't create any waste. But if so, I would say they should be directly turned to another material. Their recyclability should be very, very high. Next slide. So the association's main goals are first to create expertise, develop expertise and know-how, first of all, with trainings, workshops. Mostly we choose to create applied workshops, but surely theoretical knowledge is also important, and we should try to spread it. The standards are very important too. Now, Ant and Matthew will also talk a bit. Surely our industry also is developing in Turkey on natural building materials, but the standards are important, so we try to disseminate them. Until now, for the last 4 years, we now have more than 60 members. We already made 18 webinars, several meetings and workshops and technical trips. Next slides. We are, for the third time this year, last week we had the Natural Building Biology Forum, and the third time we are the main partner as the association. It's kind of a meeting point for the natural healthy buildings. We have an exhibition which is developing every year. Now we have many prototypes inside. There are posters about applied buildings, natural buildings in Turkey. Right now we have 15 posters about them. We have samples of natural building materials. We also made a design competition 2 years ago, and we would like to continue it, a Stop to Nature competition. Next slide, please. So, as Tanya have told, in 2023, after the earthquake, we started this research, which ended with a report, kind of guidebook on natural building materials and methods for disaster resilient cities. We started with Gaziantep because Gaziantep was in the epicenter of the earthquake, and truly Kilis, Adıyaman, and Antakya were very much affected cities. So we started our 4 days field trip. We met lots of enterprises, institutions, the municipalities, provincial directorates, industrial zone administration, architects, NGOs, and also surely universities. Following the field work, we made a literature review and continued for 4 months. And then for 5 months, we wrote the report. The main output of, next slide, please. Sorry, before the outputs, in the field trip also, we mainly saw as raw materials, I will say, which can turn out to be a natural building materials, were the mineral ones, mineral raw materials such as stone, gravel, and clay. Stone especially is very much used in vernacular architecture also. We can see in Gaziantep especially. And we saw also a very refined craftsmanship about stone. Waste materials originate from quarries or excavation sites could be a potential for the area. Agriculture byproducts as stalks and bark, but also reed marsh near Adıyaman could be used for raw materials. Also, there was forest areas in Kahramanmaraş and partly in Hatay region. I will also, you can check the report in WWF website as PDF. I can also generally talk about some output of our report in the next slide. So we can, especially in our literature review, we try to really ground our argumentation with really scientific knowledge and the first referenced knowledge. And there also we saw that Arndt will talk more about environmental performance, so that the natural building materials have minimum, even negative CO2 emissions most of the time, whereas conventional products are significantly higher in this sense. Exploring the local potential of natural building materials and promoting their use will accelerate the sustainable transformation of the built environment, and we think that enable the creation of disaster-resilient living. This study also highlights the importance of both industrial production of natural building materials and methods and their inclusion in regulations and zoning plans. But in order to really be integrated more in the regulations, we need to make more research fields so that the information become more regional centric and more in situ, I would say. So in this context, cooperation with central and local authorities is very, very important. Thank you very much. And the word on.
Great. Thank you very much for your introduction, Merve. So I will go on now with the environmental performances of these natural building materials, and there are some on this slide and the next slide, some comparisons. We don't have the time to fill you up with 100,000 of data now, but it's more generalized. So first talking about the low ecological footprint, and the ecological footprint is also the CO2 emissions, but also the embedded energy, the low embedded energy for producing them. So you can here see now the differences between glulam, lumber, steel, concrete, clay, etc. We can add a lot of other materials surely now, but if we had, for example, here, you see that steel is very high, but aluminium, for example, also as a very much used building material for facades and windows and frames, mostly. The production of aluminium has a much more higher, 3 times more higher, at the average 3 times higher embedded energy usage than steel, for example. So that's very important, and here we see how the natural building materials are on the low level. Next, please. Thank you. And here again, comparison between the thickness and the emission. So the red point are the emissions, and XPS or aerogel panels, for example, they have more emission according to their thickness, as we see. Then some are in between, but hemp fiber, board, and straw bale, these are important because they are in a minus here. So that's more valuable to have the emissions in a minus level. Next, please. So talking a bit about the diversity of the natural building materials. The last 15 years, the last 10 years, 5 years, we have a real newborn or renaissance of these natural building materials, because they are more and more produced industrial and with standards. So here are some examples with also in the middle, for example, acoustic panels. We can build them with natural building materials, and the raw material is again wood fiber, for example, or we can use it with waste paper, things like that. Next, please. And here again, a comparison with natural and not natural materials. On the right side, that's a count system which the German Institute for Building Biology has developed, and we are also using that. And the polyurethane, for example, XPS materials, they are on a minus degree. And if we can have a short look to to them who has the most points, these are number 9, 14, the calcium silicate plates, and number 17, for example. These are the wood fiber boards with a low density, and wood shavings with a blown, which we blow. So these, for example, are on that counting system, have the result of the most ecological, let's say. Also here, reed on the left side, thank you, is the isolation material which uses the lowest energy to produce it. And for that, we have very big potential in Turkey, for example, to produce reed, and it can be turned to a big economy also. Next, please. Thank you. So there are ram dirt walls. Ram dirt walls are not coming from the tradition, because we need very strong mold plates, which we didn't have in the past, but now we have it. And to compress them, we have the technology to compress them. So that's why the ram dirt technology is growing more and more. Clay plasters, clay panels or clay paints are produced in Europe, also in France, but more and more also in Turkey now. And the Natural Building Material Association is in cooperation with these startup producers, also for the standards that they can develop their products close to the, let's say, European standards. Thank you. So I will give the word now to Mathieu, and thank you.
Hello, everyone. Thanks a lot, Daniele, Merve, and for this introduction, for this presentation of the role of the association and the type of materials that we can find. I will speak more precisely on our research work that we did after the earthquake in Gaziantep, and which type of system we could identify that would be suitable for rebuilding, or at least inspiring people for rebuilding new system. The system and the work we identified were especially for structure in rural area, not in cities, and therefore all the system we identified were based on timber structure and not using any kind of reinforced concrete structure. However, all the solution we are presenting would be suitable for it. So first, please, next slide, it was good. I just wanted to show some examples of already existing building in Turkey that are using these materials, and we were inspired by those existing structure like this, a farm in Tekirdağ region, in northern region of Turkey. that is built out of light clay, a timber frame structure, and a light clay material that is creating a wall that is incorporating the timber structure in, so creating a full insulation all around the building. Next slide, please. Or here, another building based again on a timber frame structure, but a totally different constructive solution where both insulating elements such as clay panel, such as reed panels that we can see on the left side of the picture, and mud bricks are placed together in the timber frame, and therefore both acting as insulation and thermal mass to regulate the temperature inside the building. This building is in a hotter region in near Izmir. Please, next slide. So the material we identified that could be used as here, and we just also have seen them how they could be used. So not only the material itself, but the building technique and the system, and to which ways they could contribute to create a resilient building. So, and we just evaluate according to the literature and experience their seismic resistance, flood resistance, fire resistance, or heat or cold wave resistance. That's this work. And then for the work we presented, we decided to only work on timber framed wall, as most of the time, due to earthquake regulation, load-bearing walls are not allowed in Turkey anyway. Please, next slide. So here you can see some 3D views of three types of timber frame wall with three types of different insulation. So it could be walls based on using heavy materials such as mud bricks or compressed block as an infill material, and it is especially suitable for building in a very hot region as it was in Gaziantep. But of course, the climate is not always the same, and Gaziantep and also all the earthquake area was not only Gaziantep, it was also mountain area with much colder climate, and therefore we also identified solution based on more insulating material as a solution 2A and 2B. Those solutions are based on using more insulating material, less masses, especially on the exterior wall, and therefore creating a very good insulating skin all around the building. So next slide, please. So here you can see more in detail the solution based on mud bricks. So the idea is, as we saw in the second picture of my presentation, to use a timber frame, and inside the timber frame to use insulating materials such as reed mats, and on the front of it placing mud bricks. So therefore it prevents the heat to enter the building, but at the same time we keep a high thermal mass and regulating the temperature and the humidity due to the quality of earth block. This timber frame needs also additional elements in case of earthquake, and then that's where you can see from the number 4, we have to add exterior panels or exterior bracing boards to prevent deformation in case of earthquake. So all this building and this proposal are, of course, just possibilities. All of them needs to be calculated. The dimension of the timbers and insulation needs to be calculated by engineer according to local conditions. But these are possibilities to build and giving an idea of what can be done according to Turkish regulation. Please, next slide. So here you can see the different possibilities while using heavy material inside the wall and having a lot of thermal mass. What I mean by thermal mass, for the ones that don't know, is using a heavy material such as earth mostly, but it might be also stone. And this material allows to regulate the temperature while accumulating energy and preventing overheating inside the building. Therefore, this mass should not be in contact with any other heat source during the summer. Please, next slide. Another solution is to use reeds, also not inside the frame, but at the same time using it as a cladding, as it has been traditionally used as a roofing material in several regions of Turkey or Europe, but now new techniques allow to use these reeds as a cladding material. It's a waterproof material, and due to its thickness, makes a very good insulation material. Please, next slide. Or, of course, to keep bigger thermal mass, the reeds panel can be used on the exterior of the frame and then help to support also and to hold the plaster, because it is a very good surface for it. Please, next slide. Not only we need to work on the systems that are making the wall, but floors are extremely important, floors and roof. And here I'm presenting a technique that is called in English reels of earth, and it's basically a mix of straw and earth that is used as some kind of sausages, let's say, and placed in the roof or in the floor to add another mass. So it has a disadvantage is putting mass in the building, but it has a very good advantage is it can be used as heat insulation, sound insulation, and preventing heat and storing heat to prevent overheating. Please, next slide. So here in this slide, you can see the second type of techniques. That in number one, you can see light clay, which is a material made out of a lot of fiber and using the clay, the earth, only as a binder. And these kind of techniques allow to make a very good distribute insulation all around the building. Here it's only used in the wall, but it can also be used as a roof insulation in some cases. Please, next slide. So while using this technique, because it is implemented directly on site, the bracing system can be integrated into the structure. So coming back to a more conventional timber structure that carpenters know how to do traditionally. And light clay material is here, can be made with a lot of different fiber. As you can see on the picture, here it is an experiment that has an experiment of small buildings that has been made with pine needles as a fibers and a little bit of clay just to bind everything together. But a lot of other fibers has been experimented, and from the research I led at the university, at Yaşam University, the type of fiber doesn't impact on the property of the light clay. So there is no fiber that is better. Therefore, this is a technique that can be very good because it can be implemented with whatever waste fiber, agricultural waste fiber are available around. Please, next slide. So again, here you can see in the floor, insulation can be poured in between the floor joist, since it will be closed on the bottom and on the top by using diagonal boards or plywood or any very resistant material. So it's creating boxes, and therefore any type of insulation can be poured, such as light clay, but reed species, rice husk pieces, depending again on the availability of agricultural waste. Next slide. In some cases, it can be important to add again a bit of weight on the floor, because for sound insulation issues or fire protection issues, and in this case, mud bricks and earth floor can be used. Please, next slide. A third technique that is also based on that is even more insulating would be to use the same type of timber frame wall, but use what we call loose fill insulation, loose insulation, that is based not on a material put together in a binder, but by closing both sides of the wall and filling with different type of very finely shredded material. Next slide, please. So here you can see again an experiment that has been made in Tekirdağ, in the farm I showed at the beginning. And here the walls have been filled with rice husk. So the peel of the skin of the rice when it's taken from the field. This is again a very waste material that is not used except to be burned and as a biomass, but it could be used directly in the wall. And of course, it's just an experiment here in Turkey, but in some country it is already sold as ready-made insulation, ready-to-use insulation for walls and ceilings. So, and the box is closed with boards and with reeds covered with earth plaster. So again, we gain a little bit of mass with the earth plaster, and especially we use the earth property to regulate the humidity. Please, next slide. Reeds can be used exactly in the same way. So in this case, there is no need of additional reeds mat. The reeds as a mat or as reed shreddings can be added inside the frame as a full insulation. Please, next slide. And here is an example of using loose fill rice husk in a roofing system on the picture. Or here it can be also used between the timber joist or the rafters of the roof. Next slide. So these were, of course, solutions for building in rural areas, low-rise building, 1 or 2 story, according to the possibility of the regulation. However, in Europe and in some other over the world, where there are less earthquake or where the regulations are adapted, those materials are already used for very high-rise building until 18 story in South Africa, for example, and in dense area. So here you can see the different pictures. The picture one is near Paris. It is a hempcrete building. I mean, of course, I chose all the examples to be reinforced concrete building, as it is usually the case in Turkey, but the infill, the wall infill, the facade is made with natural material. So the first one is hempcrete, a mix of hemp sheaves, hemp dust, and lime. The second one, the second building, is made with mud brick, compressed earth block as a facade system. The third building, there are straw bales placed in between the reinforced concrete columns, and the straw bales are plastered with lime and with earth. Next slide, please. So here you can see the number 4 is a stone building in Paris, but the stone facade is also insulated with hempcrete, whereas number 5 is to see that not only new buildings can be used natural building material, also renovation, and it is a renovation project in France, again near Grenoble, where straw bales are used as exterior insulation and are placed above the existing material of the building facade. So thanks a lot, and now I will let Charlotte explain her work directly, how as architect with the municipality of Rosny-sous-Bois, they are working and producing experimental building. Thanks a lot for all.
Thank you, Mathieu. Thank you, Merve and I will take it from there. I see that there's about 20 minutes left, so I'm going to be extra fast in my presentation and I'll try to be clear. So I'm Charlotte, I'm an architect. I've been working for the last 9 years in Rosny-sous-Bois. It's a suburban town near Paris, and bois means forest, but there's no forest there. Since Merve and Mathieu gave a very strong background explaining why and how we could use natural materials, I will be fast on the subjects and talk straight about our buildings. So we can go to next slide. Quick reminder that we have very different climates, France and Turkey. So obviously the design I'm going to show you, the projects are responding to our particular climate. And we have no or very little seismic activities. So obviously our buildings will be different in that effect. Yes, we expect, as everybody else, a temperature rise. And that's what we have in mind when we design our buildings. So next slide, we'll slowly approach the projects. I just wanted to say that it's very specific for a city to have a dedicated team to work on the subject of adapting our cities to the climatic and social changes. We have multiple skilled teams with architects, engineers, structural engineers, but also heat and ventilation engineers. And we also have a forest expert at the moment. Next slide. We've been working on what we call ecosystemic design since the last 10 years. As civil servants, we must question every choice, every action that we do every day. We are responsible for preserving the common good, and therefore we have to make sure that every choices we make will not have a negative impact on the environment and more globally on the planet. So because we want our town inhabitants and everybody else to keep on living in a dignified way. Next slide. In France, it's the towns that have to take in charge constructing primary schools, and then we put it at the disposal of the Ministry of National Education. So what happened in Rosny is that we had an increase in demography, more children, and not enough classrooms. That's why our team has been working specifically on building new school buildings for the last 10 years. So we started, as I said, about 10 years ago. And for our first example, we already used natural materials, but it wasn't completely satisfactory. As you can see, we used a glulam structure and straw insulation, but with very little knowledge of all those, of where the wood came from, and even for the straw, even though we had a certified organic straw paper. So from that point of view, it was not satisfactory, and we moved on. If you want to go to the next slide. Yes, and from that starting point, we tried with every project to understand better agriculture and forestry. So we could really know where the natural materials came from, and if the agriculture or forestry, where they came from, was also having a positive impact on the ecosystems. The first project, we found out that the wood was probably grown in Scandinavia and then transformed in Austria, and then it arrived in France with trucks. So we decided there was too much embodied energy and we couldn't go on like that. So choosing to build with timber and straw is good, but it's not good enough. You really have to know where the materials are coming from. For that second school, we started meeting with carpenters to find out where they got their own supply, and we asked them if they were ready to put the straw insulation themselves the building, and it's not always easy. People have their way to doing stuff, and they don't really want to change most of the time. So then we had to meet for other contractors that were willing to work with the straw, and we paired them. We found a carpenter and a straw insulator, and we got them to work together. For every school, there's loads of researches that are being made, and I'm not going to talk into much details about each of them. Well, I should say about this one that we started our research on natural ventilation. It's not exactly the subject for today, but it's important for us that the schools are easy to maintain, and that even I can work and I know how to clean the system, for example, or what should be done, so the city is more resilient with their new buildings. We could go to the next slide. What we realized as well, and we're still working on that, is that the building cannot answer all our needs. It might become impossible to be warm enough in the winter or cool enough in the summer. So we have to work first on our own bodies. That's why we met with the local knitters club, and we made a deal with them. We give them knitting wool, and they did those sleeveless vests that were available for the children. And that's the way to tell everybody the story that we need, first of all, a cultural change if we really want to have an evolution in society and an evolution of how we deal with those new climatic conditions. What we did too, and you see a picture of it, is we started install a mass stove, because we realized as well that if there's an electricity shortage, well, any heating system just stopped working. Whereas with a mass stove, you just put your wood logs in it and you start the fire, and at least you can warm up one central zone in the school. And we started thinking about our buildings as refuges as well. If there's really a problem, an electricity shortage, at least we can gather children, even adults, in our schools and keep them warm in the winter. Moving on to the next slide. We also build, this is not exactly a school, this is a building that will, well, children will go before school, after school, during the holidays, and during the days where there's no school activities. And this one is very specific because we had the opportunity to do many researches on this one. With the load-bearing straw walls, I'll get back to that, but also we continued using that natural ventilation with heat recovery system that we designed. We've done some seasonal heat storage, which is a bit complicated but interesting, is how you load up calories from the solar energy into a huge tank filled with water and reuse those calories to heat up the building for part of the winter. Next slide. So just a quick reminder that load-bearing straw walls exist since the late 19th century. It's been developed mostly in the central plains of the United States of America, where they had very little construction materials. And when the straw boiler were invented, they realized they could just stack up straw bales, just like bricks in a way. And with a rendering on the inside and outside, the building would stay there. And there's still buildings that have been built in the late 19th century that are still existing today. We have the idea that with using straw as a load-bearing material, we use less wood, because timber in a way is a very good material, but it takes many years to grow, and it's a very finite resource in a way, such as whereas a straw is growing every year. So in France, we have no shortage of straw. And we were able to build that 2-story building with all the external wall being made of those load-bearing straw walls. We made prototypes and we made fire tests, and everything worked fine. So the building was constructed. Next slide. Just a quick word on water, which is also a resource that is a very that questions us a lot anyway, and we think that it's drinkable water should not be used to flush toilets. It's just such a waste. So we've implemented those dry toilets in 2 of our buildings. And the idea as well is to use the urine as fertilizer, like it was done before we invented industrial fertilizers. And this way we can make a cycle from our building and the field of the farmers who then give us straw to insulate the next building. Next slide. Very important for us as well is to invite as many people as possible during our construction sites to make various workshops. We've done a lot of workshops with raw earth bricks, with mud bricks, because it's a very easy technique that even children can participate. And that gives us the opportunity to explain, like you did earlier on, why we should use those materials and how they're good for us, for our health, for the planet, and and even how you can use your own hands to build. It's not necessarily that you need to get a contractor. You can actually do a lot by yourself, and it gives a lot of hope to people knowing that they can do stuff themselves. Next slide. Moving on to this school. This one was very, very tricky because there was really not that much time between the moment that the mayor decided we had to build the school and the opening of the school. It was only 3 years. So the concept, the designing phase was really short, and also the building site time. So we decided we had to do prefabricated units to help us deal with that short time. You can go to the next slide. And we found a contractor that was really close to Rosny, about 10 kilometers away, and he had enough space to make a prefabrication workshop, especially for this building. So it's very simple. The outside walls are made of those timber, I don't know how we'd call them, structures, units, and it's filled with straw bales in the workshop. And it's also the inside rendering made of earth is also made in the workshop. And then we just had to carry all those units to the building site. You can see part of the structure on the right-hand side. I didn't say it in, I didn't pinpoint it, but all our structure in wood is made of massive wood, local wood. So it's mainly deciduous wood as oak or chestnut wood. And the structure obviously is on the inside, and the prefabricated units are making all the external walls. So that was really effective. We also did on that project, if we go to next slide, we also did an experimentation from the forest to the school, where the town actually bought wood for a nearby forest, and we added the saw with a portable sawmill. So the wood had really little kilometers to make. It's only about 80 kilometers, I think, before being used on the school. Since the wood was not completely dry, we only used it for external structure, as you can see, the canopies on the playground. Next. Yes, I have very little data to share, but after we completed all the projects you've already seen, we did some survey to see how was the building, how was the inside temperature in contrast with the outside temperature. So in the summer of 2022, we monitored one of our buildings for the whole summer, and this is the hottest week of this summer. And basically, the inside temperature is always around 25 degrees, even though sometimes you have a maximum outside temperature as high as 35 degrees. So without any air conditioning, our buildings are holding up very well for the moment, even when there's very hot summers. Next slide, it's the same for the whole summer. Next slide. Thank you. For this project, we did a specific research on raw earth. So raw earth is a bit of it's a bit complicated for us because it's very useful as a render on straw. It works very well, but at the same time, it's not a very local resource for us because in Paris and the suburbs, the earth is polluted. So it's complicated to use polluted water inside raw earth inside a school. So we use it because it has next slide, it's very good to add inertia to our buildings and to help them being cool in the summer. So on this one, we did a research on load-bearing straw walls, and also we did the internal lining to add more inertia to the buildings. Next slide. And yeah, we tried as well, and that was an open workshop, so people could come and do the filling of our wooden floor with earth and straw. Next slide. And that's an illustration of how you can use all kind of wood, and you don't need to wait for 100-year-old oak to build a structure. You can use very small sections, and there's tons of different ways to do those how do you say that, trusses. And this one is a Delorme trusses used with very small sections. Next slide, and I'm getting near to the end. Quickly, we've also worked on renovating a 1960s school. It's a concrete building, very simple, so a lot of energy consumption in the winter and too hot in the summer. And we've made a very nice straw coat that we put all around the existing building, and we've added as well our natural ventilation system. And the research, next slide, for that last project was very specific on perennial cereals. We've decided that there was a way to use straw with even less embodied energy than the usual organic wheat straw that we've used previously. And we've worked with the Land Institute that is in Kansas in the USA. And they have research all over the world, and even in France with the Institute of Agriculture in the Rhône-Alpes region. And we were able to test that straw with Tinopyrum intermedium and to realize it would work just as well. And it's a cereal that grows for 3, 4, 5 years in a row without the need of going in the field and using the tractors every year. So there's much less petrol used, and we're really happy that it works fine. And we are planning to keep on using it for the next projects. And finally, the last, just a quick word to say that we're very happy to do schools because it gives us the opportunity to work with children. And it's important, they're the future, and they learn very quickly, and not like us adults who sometimes have difficulties imagining a future. Thank you very much. I forgot this slide. Yes, it's just to show that with the new buildings, our overall energy uses has reduced drastically in Rosny.
Thank you very much, Charlotte, and all our speakers. It is very fascinating to see how nature actually can help us on our fight against climate change. And it's also, I was also amazed to see on your work in Rosny-sous-Bois how to include the communities on your work, and increase the awareness in this context. And now we have very little. We have actually on time, but maybe just to turn to our audience if they have any question. One of our audiences has asked if we could share the presentation. Of course, we will. I see. Now, in that case, I have one question to all of our panelists who wish to answer just in 1 minute maybe. In your experience, what is the main barrier that you come across on your efforts to extend the application of natural building materials, and how do you intend to overcome those?
Maybe Charlotte, as with your experience, I mean, you already overcome, I guess, a lot of barriers. So maybe you can answer first,
Yes.
and we can share the experience of Turkey after.
Well, very briefly, what was important to be able to do all those experimentations was to meet with the different actors, and to, as I said, go and meet farmers and foresters and contractors, and to do that even before starting to design, so we know what was available or what was not be available. And then the second thing is that all the person in our team are have done a lot of formation trainings in natural materials, and we do it ourselves. We actually go and meet all those people, and we train. So that's it. It's training and knowing the environment that help us to move on with our project. Very little barriers, really.
We
Thank you
can
very
continue
much,
from here to answer the same question. In Turkey, we have one more barrier. Most of the time in the application phase, we designer, architects could not sometimes find the right producer or applier also with the know-how and enough background. This is another barrier for us.
Thank you very much.
Most of the time we are doing, we're also implementing the design that we're conceptualized.
Mathieu, would you like to add anything?
No, I agree. I mean, it's just a lack of knowledge about the materials themselves, that they may even exist and that it may even be possible to build, that is creating the main barrier. So that's, I'm really happy that we can have this event today and share the experience of other countries, other municipalities that have done it. So it's possible to show that it is possible in any condition, even with earthquake or very harsh climatic conditions.
Well, thank you very much to all our speakers and all our audience for being with us today. So now I'd like to conclude this webinar, and hope to see you all in our next events, maybe.
Thanks a lot.
Thank you very much.
Thank you.
Thank you.
Thank you. Bye.
Have a good day, everybody.
Bye.
Bye-bye.
You too.
Bye-bye.
Thank
Bye.
you. Bye-bye.